Hello everyone, this is Sandeep Giri here. Are you able to hear me clearly? Is my voice coming through clearly? Just a second, I'm going to turn off some things. All right. So, hi Bala, hi Gaurav, hi Martin, hello Naveen, hello Randhir, hi Rajiv, hello Ravish, hello Srini, hi Suhas, and hello Venkat. So, could you please introduce yourself? Could you please introduce yourself? Hello everyone, is my voice coming through clearly and my screen is visible to you? All right. Hello Gaurav and great to see you here. Hello Srini. All right. Hello Randhir. Randhir is from Houston, Texas. Great. Is my voice coming through clearly to everyone? Please respond to my questions through the questions window. Hello Venkat. All right. All right. Great. Great. So many questions. Looks like there was some network glitch. All of the questions have just now came in. All right. Great. Great. All right. So everybody except for the instructor, which is myself, everybody is muted. So you have to talk to me. If you have any questions, please ask using the questions window. So this session is divided into two halves. First half is dedicated to understanding big data. Second half is dedicated to understanding Hadoop and the ecosystem. And in the midway, there will be a 10 minutes break. The session is being recorded. And after this session, maybe in couple of hours, the recording and presentation will be shared to you. All right. If you are a student, then it will appear in the learning management system. Otherwise, for the first session, if you are just attending the introductory session, for the first session, you will get the presentation and the recording in the email. All right. Yes, Susant, you have to type the questions because there are many attendees. So it will not be possible to unmute everyone. So, all right. And great. So everyone except instructor is muted. You please ask your questions by typing in the questions window. And instructor will read out the question before answering. So everybody knows. All right. Just give me a second. Let me turn off. All right. All right. So, all right, let's jump in. So this is the session one out of our 11 sessions on big data and Hadoop course. It generally suffices as a very high level overview of big data and Hadoop ecosystem. All right. So let's jump in. All right. So Venkat's question is when I will get the access to the labs. You will get the access to the labs as soon as you register. Have you registered already? All right. All right. Let me check if you have gotten the access or not. All right. So you will have the access login password the day you register. It's just that I need to explain to you how to use the various facilities. All right. That we will describe you tomorrow in tomorrow's session. All right, Venkat. Great. A little bit about no big data. So no big data started with a clear objective of providing the expert instructors in training. Instead of having a instead of having very experienced instructor in general, we focus on instructor who are great experienced in the industry and are generally hands on. All right. For this session, I will be the instructor, and I have developed in past on the ouch, the network is fluctuating. Ouch, the network is fluctuating, so I need to see what's going on. All right. All right. S Okay, so we focus on expert instructors. We have a unique proposition called CloudX Lab. And in the CloudX Lab, it started as name called Cloud Labs, but somebody has registered the name, so we are changing it to CloudX Lab. Okay, so the CloudX Lab is our unique product which others do not provide, and the objective is to make the learning really, really easy. So we provide you the lifetime access to learning management system, including presentations, class recordings, assignments, and quizzes. All right. Now, the real life project we provide to the candidates if they really excel in our normal project. The course completion certificate is provided to everyone, but the course excellence certificate is only provided to few. And we provide you a 24 by 7 support. Along with that, we have a group called No Big Data Alumni. All right. So in the alumni, the group is for sending the notifications regarding the jobs and and also keep you updated with the complimentary sessions or new content such as quizzes, and also stay connected with the industry. All right. So Pankaj's question is, can we download also or the lifetime access from your or only the lifetime access from your lab? Okay, am I missing? There are a lot of questions, so let me answer questions one by one. All right. This text is clear to you? Is the font good enough? Le- All right. So great. Let me just read out lots of questions we have. We have Ravi, Justin. Hi, Justin. Hello, Ravi. All right. Okay, we have answer to this one. All right. So Venkat says that when he's trying to log in with my ID, it says credentials are wrong. All right. Let me. So the credentials are visible on your My Course page, and there is a login, there is a password. All right. We will discuss it maybe offline. Right. Here's a question from Here is a question from Ravi's. As an engineering graduate, how big data is going to help my career? So big data solutions are good when you have dealt with small data first. Okay. So if you are aware of what exactly does SQL do, and you are also aware of the basic programming language, any programming language, then you can go ahead with big data technologies, because big data technologies stand upon the basic technologies and provide a suite of components which are specifically designed for handling humongous data. All right. So it is very obvious that we require the basic knowledge of the data handling techniques, such as a bit of programming language, bit of Unix shell, and a bit of SQL. All right. So those are the basics required. And once you have done that, you definitely can. There are many opportunities in the industry for at various entry level as well as experience level in case of big data ecosystem. The good part about big data ecosystem is there are only few companies who are asking for experience in Hadoop, etc. But most of them want the experience in the basic technologies more. All right, the knowledge is good enough. All right. Now there's a question from Pankaj. Uh, can we download also? Yes, but generally our download system does not allow you to do that. Okay. The tools which we are using for hosting our videos, they don't allow downloading right away out of the box. But there are third party solutions, third party downloaders using which you can download. All right. If you want to download, you can download. If you are not able to download, let us know. We could help you with those tools with which you can download. All right. All right. Also, or only lifetime access from lab. So the cloud lab is only for 50 days. It's not for full lifetime. Is the LMS is for lifetime. Lifetime, either our lifetime or your lifetime. So if the company survives for as long as time, the videos and everything will be available to you. All right. So next question is 50 days. And moving ahead. So Ravish, was I able to answer your questions with respect to prerequisites? Martin's question is, should we understand statistics to have a career in big data? Not really. Okay. Uh, okay. Not really in general. Okay. Yeah. Yes, in case you are planning to go ahead with analytics and analytics and data scientist data scientist course. Okay. So let me just 7 October. All right. Should we generally, yeah. All right. So in case you are planning to go ahead in your career into analytics or data scientist domain, then knowledge of basic knowledge of statistics is required. Like for example, you should know what does it mean by summary statistics, how do you compute mean, how do you compute standard deviation, as well as you need to know what does it mean by root mean square value, and also uh, what does it mean by the the various the the central mean theorem. There is a theorem, and so basically if you are going with data analytics and data science course, then you do require a good understanding of statistical analysis. Sushant's question is, how easy or difficult is it to excel in the course? What are the real time projects pertaining to this course? Okay, so as we go ahead in the course, you will see there will be project or small assignments and exercises pertaining to each session, and it's not very difficult. I would say, I would answer to this one in a single word: it's a medium difficulty course. It's not very easy course, so you should not take it lightly, because the assignments are aggressive. There are subjective assignment as well as objective assignments, so you have to complete both the kind of assignments. Only then you will get the grip of the course. Okay, if you have enrolled for this course, make sure to finish the assignment as much as possible. Wow. Okay. All right, there are many questions. So what are the real-time projects pertaining to this course? So real-time project, it's a real life project, I'll say. So there are two kinds of project. One is the theoretical project which we provide. We think that those are very nice industry level products, but they are not really real-time projects or real life projects. Okay. Now, what does it mean by real-time or real life project? It means that generally many people from industry approach us to solve their problem. Okay. So I guide my students, or we guide our students and connect our student who has really done a great job, who has earned that kind of respect from our side. So we connect them to the industry. For example, our current student, his name is Abhinav. He's working with a company called Dell to solve their order predictions. I mean, how much time will it take for an order to deliver, just based on the data science. Okay, so he's working with Dell to solve their problem. Okay, they have a 45 million events every day that need to be analyzed. Okay, so that is a real life project. So Srini's question is, what if I need access to the lab for more than 50 days? You can let us know. You can let us know, and you can pay around $20 for 1 month extra access. Can you suggest a book to go through along with this course? The good book which we suggest is generally the definitive guide for Hadoop. You can go with the definitive guide for Hadoop, and we will suggest you more books as we go through the course. Okay. All right. So Asi's question is, what is the difference between Hadoop and HPCC? All right. We will discuss these questions later. And Gaurav's question is, I am from mainframe technology background with DB2 SQL experience. Tell me about scope for big data for a person like mainframe background. All right. So all right. So there is definitely a demand, and you basically, if you are coming from a DB2 SQL background, so you meet the prerequisites needed for the courses like this. Okay. So you meet the prerequisites of the for required for this particular course. So as I was telling you, you should know basics of the following. Okay. One is programming. Any programming language you should be comfortable with. I mean, you should just know what's a for loop, what's a while loop, and that's all. What is a variable, and what does it mean by assignment? Now, basics of programming, ba- basics of programming language, anyone. and SQL, and you should also know basics of Unix or any command line. All right, all right, such as how to list files, etc. Okay, so that's pretty much what is required. So I mean, if you are fitting in that, then you can take care of it. All right. We have a question from. All right. Ravi, are you able to hear me now? Looks like you lost the audio again. All right, great. Now I have seen Java videos on your website. You say bit of SQL and Unix cell knowledge. Can you provide the details? Yes. So most of these things we will teach you as we go ahead. All right. You should know when you say SQL. When I say SQL, it means that you should know what does it mean by a where clause. How do you select the data from a table, and what does it mean by joining the two data sets? That's all. All right. And when I say Unix, you should know what are the files in a folder, how to find out, how to create a directory, how to copy the files into that directory, and so on. So those basics of these things, so that you can interact with the existing tools which we are going to train you in. All right. So Gaurav, since you are when you say that you are from mainframe, so you know DB2, you know COBOL, and of course you will be knowing a basics of Unix. So there is nothing stopping you from going ahead in this course. All right, which is a preferred programming Java or a functional programming. So for this case, for this particular course, our preferred language is Java, and we don't bind ourselves too much. So Java for MapReduce we will consider, as well as we will do a MapReduce uh, in Unix also. Okay, okay, Unix shell scripting. So the idea in MapReduce is we will try to show you that MapReduce can be done in any programming language. All right, and then we will go with Python for our Spark. So there will be a 2 hour session on Spark, which should be sufficient. In that, we will just go through the basics of Python and we'll go ahead with that. All right. We provide you a free Java course along with this. All right. Srini, your question is what specific areas are covered in this course? Probably this will give you an idea, and we will talk about this during the session. All right. So we are looking at the Hadoop developer. This course is designed for Hadoop developer. All right. And for becoming even the architect, this course is mandatory. All right. So either you are aiming for big data architect or you are aiming for big data developer. For both, this course is mandatory. So Venkat is saying Java videos in website are only for self-learning, or are you going to cover in your classes? No, we are not going to cover the Java in the instructor-led training. Java videos have been provided as a complimentary to all the students who want to brush up or who want to learn Java. Okay, it's a very fast-paced Java course. All right, and so Naveen's question is, can you tell us what projects or datasets will we use? So whatever projects or datasets will be using, we'll put it in our CloudX labs. So for example, we'll consider the sentiment analysis, we will consider the recommendation generation, and we will also consider few more exercises of cleaning up the data. Venkat's question is, are you providing course for Hadoop architects? So this course is the first stepping stone for Hadoop architect. All right. All right. So good. Now moving ahead, a little bit about myself. Please feel free to tell me about yourself. That will be great. All right. So great. We have more than 25 people in the class, and all right. So a little bit about myself. I am Sandeep Giri. I did my graduation in 2002 a long back from IIT Roorkee. And after that, I joined a company called DE Shaw, where we built big data systems before the term was coined. So we had a 10,000 node cluster at that point of time, and we had data which was difficult to be transferred online. So we used to get our data via offline mechanisms such as uh, through air or through the ship. Okay, so at the time we had those big data challenges long back. Then I started a company called Tbits Global, where we built an enterprise grade document management system. And afterwards I worked with a company called Inmobi. I built recommender for them, which used to churn around 200 terabyte of Apache logs. Afterwards, in 2012 itself, I joined Amazon, worked there for 1.5 years, and built their internal stream processing system for selecting the images for their detail page. Now, in 2014, realizing that there is a gap in the industry, realizing that lots of people who are training big data do not have the depth and do not have really worked on any of the systems, I decided to start a learning company. Okay, so the idea is twofold. One is providing helping in various open source products. Along with that, the main objective of no big data is to provide really good learning experience for our students. All right, so that's about me. So Veena's question is, does a developer use all these tools, Hadoop, Hive, HBase, etc., or only one at a time? Generally, your project comprises of multiple components, and we will discuss it in detail at later point of time. Okay, I'll give you a quick example. For example, when I was building my recommender, we were having multiple components. We were having some part of the map reduce, okay, which was written in Python. Then we had Uzi running for the workflow. Then we had Hive cleaning pipeline. Along with that, we had Mahoth pipeline. So basically, we were using 4 5 components at the same time. Generally, whenever you are building a project, you use multiple products. All right. All right. So we have just a second. Let me do a soft rep. Yeah, this is better. Great. So we have Martin from Indonesia. He works as a Teradata consultant, and he's interested to have a career in big data and Hadoop and plan on certification. All right. Martin's question is, could you help sharing about question types for Hadoop Hortonworks certification? Yes, we will try to help you with the Hortonworks certification. All right. Great. All right. So let's start the session now. So we have a great half an hour discussion on the general aspect of big data, general career related questions on big data. Let's jump in with the main problems of big data. All right. So here we go. So first question which everybody asks and everybody wants to discuss is, what exactly is big data. So anybody? All right. Vinayak says use unorganized data. Big data is basically large amount of data from different sources. That's the next answer by Bala. Okay. Sushant's answer is a very big chunks of data which cannot be managed by small data tools. All right. Martin's question is large amount of data that need to be analyzed and that cannot be handled by traditional data management technology. Brilliant. Venkat's answer is data which is not handled by traditional database management system. Brilliant. All right. Now, okay. So before we start anything, we will just zero down on the definition of big data. So big data is simply data of very big size that you cannot process using usual tools. Okay, and to process such data you need distributed architecture. The data could be in structured form or unstructured form. All right. Hi, so are you able to hear me? Looks like the connectivity is really real pure. Hi, are you able to hear me now? Hello? Yeah, I'm so sorry. The connectivity is going really bad. Hello? All right, I'm so sorry. The connectivity is a little bad today. Although I have two network connected, but the switching is taking time. All right. So Pawan's answer is big data is used for processing possibly process huge amount of structured unstructured data and to generate report basis on analysis. Okay. All right. Great set of answers. I will stick to this definition of big data. When we say big data, it means big data, as in data of very big size that you cannot process by using usual tools. You require a distributed architecture. Okay, data could be of any form. So The most important part of our definition is this. Okay, the distributed architecture needed, the kind of data for processing which you require distributed architecture. All right. And when we say structured and unstructured or semi-structured, this is the definition which we will go with. Structured means we know the fields in the data as well as we know their data types. So when somebody gives you data, you ask, is it a flat file? Does it have fields? And what are those field types, right? If the answer is yes, it has got fields and these are the fields, and these are the data types of each field, then the data is structured. Okay. Answer so you can say a database table is structured data. And when we say semi structured, it means the we know what are the fields in the data, but we don't know the data types of each field. Okay, for example, CSV files. We know that in a CSV file, what are the various columns based on the comma separation, but we do not know their data types. Third is unstructured data. This is a raw data in which we do not know any field so far. We need to parse it to recognize the fields. The answer could be, in case of unstructured data, the example could be the data which is from Apache logs. Apache log, as in there's a web server called Apache. When you are requesting a website, it makes a record of it in a file, and this file is called a log. Okay, and that information about who accessed which page, what time, from what IP address is very crucial and important information in doing lots of predictive analytics. Next is the distributed computing. What do we mean by distributed? We use the word while defining big data that to churn such kind of data, we require distributed computing. And this is probably the most important idea in big data. Okay, so you take group of computers, network them together, and let them interact with each other using a software, and the overall objective of this whole cluster is singular, as in they need to work together to solve a problem. Okay, or in other words, you have a problem you are asking all these computers to solve. Okay, so this is distributed computing. Solving your computational problem using multitude of computers simultaneously is called distributed computing. Make sense to you? All right. So these are the three characteristics which we will talk about. We'll not talk about other V's right now because those are secondary and those are not part of the basic definition. All right, we will clear this definition as well. All right. Okay, so the three characteristics of data which might make it big data, which might make it so that you cannot solve your problem using a single computer and you would require distributed computing. These are the three general characteristics. First is the volume. Volume means data at rest. The data you have gathered, where will you put it? How will you solve the storage problem? That kind of problem is called the data at rest problem, the volume problem. Okay, for example, Facebook generates so much of data every day. So many people are creating the content continuously. Every second there are millions and millions and millions of records that come to Facebook. Where will Facebook store it? That's a volume. The characteristic called volume forces an organization to to need distributed computing. You need you when you have to store hundreds of terabyte of data, you cannot store it on a single computer. And to solve such kind of data related problem, storage related problem is called the volume characteristic of big data. Second is the velocity. Can you imagine how many requests go to Facebook every millisecond? Everybody's phone is sending a ping to Facebook, and and everybody's computer is sending a ping to Facebook. So can you imagine how many requests go to Facebook every millisecond? Now, can those requests be handled by one computer? Can one computer handle so many requests? The answer is obviously no. Okay, therefore velocity might also push you to use distributed computing. Velocity of data, this is velocity, lots of requests coming per second, is the velocity that might push you to convert your solution into a solution which uses multiple computers. All right. Third is variety. The characteristic variety is very interesting one. Variety refers to both the things, the kind of problem you have and the kind of data structure you have. Okay. So sometimes variety forces you, or variety, because of the variety of problem and the data you are handling, you cannot get it done using single computer. All right. So let's take a case of variety. Imagine that Google Maps data, there is so much of data. I mean, so let us think of for a moment that you are given a huge map of the world, which has every city. Inside every city, it has every street and every corner. Now, based on this map, you have to provide the path from one point to another. Okay, the map, let's say, even if we break down the map into, say, per city level, and per city level the map could be hardly 100 gigabyte. All right, now out of this 100 gigabyte, out of 100 GB data, if you have to find path from one point to another, it's actually fairly tricky game. It's fairly complex, and it might take a lot of time for you. And therefore a problem like maps require more computing. Or you can think about other problems related to finding a cure for cancer. Okay, so the data might be smaller, data might be say 100 gigabyte, but trying so many computational permutations would be almost impossible. That leads to variety, and those kind of problems can be well solved by multiple computers parallelly rather than using a single computer. Okay, similar is the case with finding recommendations, recognizing images. So all those kind of problems, although the data may be small, or and there may not be velocity, but due to the nature of data and nature of requirement, our problem could become the big data problem. Or we might realize that one computer may not be able to solve our problem. All right, is everybody clear about the characteristics of big data? Great. All right, so these are the three basic characteristics of big data. Now, question to all of you is, how many bytes are there in a petabyte? Anyone? All right. There's a question from Sushant. Question is, what is the difference between distributed computing and big data? So big data is a problem and distributed computing is a way of solving those problems. Okay, big data, along with that, big data tools are almost all of the tools are have the characteristic of distributed computing. Okay, great, great. So almost everybody is correct. So a petabyte is 10 to the power 15 bytes. Great. All right, great. Great. This question was just to check how well you know these numbers. Now we will, the good way to remember the table is using this kilo mega giga tera peta exa zeta iota, and the next one is 1024 times the previous one. All right. Now question to all of you. Let me see if can anybody can answer. Is 1 petabyte big data? If you have to count just vowels in 1 petabyte data every day, if you have 1 petabyte data and you have to count just the vowels, how many vowels have we encountered in this 1 petabyte data, and you have to do it every day in 24 hours, can you do it without distributed system? Can you do it using one single computer? Anybody? All right. So Venkat's point is yes, no based on data variety. Okay, let me further clarify. This data which we are talking right now, this is plain text file containing the text. Now, all right. Ravi's question is by reading small data, it will take a long time though. Okay. Now here the question is you have to do it every day, which means you have to get it done at least in 24 hours. What is Abinito Suhas? All right, there is a point from somebody. Distributed computing is a parallel processing. Yes. So actually, parallel processing earlier was the situation where we were using the same RAM, but different CPUs. That was parallel computing. But now, and distributed computing was using multiple computers itself, different computers. But now, parallel computing and distributed computing is generally used uh, interchangeably. All right. Justin's question point is, can we keep time for questions later? Mm, other so Justin, these I would okay. All right. Let's try to keep the extra questions at the end of at the end of slide. All right. Let's not interrupt the flow. Thank you, Justin. All right. We will try to keep the questions which are not related to the topic for the later point of time. All right. So almost everybody is of the opinion that we cannot handle big data. We cannot handle 1 petabyte using a single computer, which means 1 petabyte is a big data. And the reason is, I'll explain to you the reason. The reason is this: how much time do you think it would take to read 1 terabyte from one hard disk? Okay, you don't have to retain the whole 1 terabyte in the RAM. Okay, you just have to read from SD. Okay, just count the vowels and then keep on reading from a hard drive. So how much time do you think it will take? Bala says 3 hours. Okay, anybody else? Okay, Ravi says it will take 5 to 10 hours. That's correct. So it takes around 5 to 10 hours. That's correct, Ravi. So, all right. So time taken to read the data, read 1 terabyte data from hard disk is around 6 hours on very fast computers, but it will depend on the drives. That's correct, Bala. So yes, it depends on drive. What if we are using solid state drive? The speed will become really 10 times. All right. So, all right. So, which means that just to read the 1 terabyte data is taking 6 hours. That means if we try to process 1 terabyte data in any other means, it is going to take huge time, and therefore it is impractical to use a single computer for processing one petabyte data. When it's taking 6 hours for one terabyte data, here we are talking about 6 hours, and here we are talking about 1 petabyte, which means 6,000 hours it will take for one computer to read that much data. Therefore, it is almost impossible to handle 1 petabyte data using a single hard disk or even few hard disks. All right. So to churn 1 petabyte data on time, even for 5 hours, it will take you around 500 computers. Okay, the 1 petabyte sounds really cool. It looks very simple. 10 to the power 15 looks really small number, but in reality, when you try to handle that much of data, you will realize that it will take a lot of time to churn that kind of data. All right, does it make sense to you now? So to read 1 petabyte data from a single hard disk, if there is such an hard disk, it will take 6 into 1000 hours. Alright, so this is a classic diagram which shows that the data, digital data has grown really bigger over a period of time, and it started in 2002. So what is it important now? Why we are talking big data so much now? The reason is because of smartphones. The data production from various users have become really high. Every user is producing so many emails, so many Facebook updates, so many snapshots, so many call records. Every second people are producing data because of the smartphones. The devices have become cheaper, faster and smaller. And on the other hand, when we say devices, it also means the other devices, the Internet of Things kind of devices, where you have all sensors, connectivity, and everything. So, on one hand, you have got devices which have become cheaper, faster, and smaller. On other hand, the connectivity have become very prominent. Now, devices are talking to each other over Bluetooth, over Wi-Fi, over over 3G, 4G, and 2G, and there's so many ways to connect one device to another. So as of today, because of devices becoming cheaper, faster, and smaller, and connectivity becoming faster and present everywhere, the data is getting generated in a very high speed. Okay, now what should we do with this data, that we will again consider later. Now, there are important use cases right away, such as social networks, which are produced, due to which the there is a reason why people are producing data. Okay, people are sending videos, watching videos on YouTube, people are sending updates to friends over the Twitter and Facebook and Google Plus, Flickr, Yahoo, and whatnot. Now, here is a question to all of you. All right, so we talked about few things, that devices have become faster and all that. Then the question is, when we talk about computing, when we say that, okay, we our computing will we have got a computer and this is really fast, what does it mean? Which computer components impact the speed of computing? Which components out of your server will impact the speed of computing from A to Z? Anyone? Great. So, all right. So yes, you all are right. G, all of above. This is something which we need to understand. And when I meet lots of people, I find that lots of people are not able to understand this part. That when we talk about computing, it's not about Pentium 3 or Pentium 4. It's not about number of cores only. It also means other factors that impact the computing. For example, if your computer is slow, try upgrading the RAM. If your server is slow, try upgrading the hard disk from normal hard drive to solid state hard drives, and you see the difference. Okay? If your program is slower, you will have to figure out what is the bottleneck. Okay, it could be any of these components from A to F. All right, let me just go over these components quickly. So you all know already that these all four components matter. CPU, when we talk about CPU is a device which switches between switches I mean which reads the instruction and executes the instruction, which reads the data from RAM and writes the data back to the RAM. CPU gives instructions to various devices and various hardwares. Now, the second most important component out of your computer is the RAM. When we say RAM, it means two things. How big RAM do you have in your computer, and how fast RAM do you have in your computer? All right. So some people think that if they divide RAM into two and run two virtual machines, then suddenly two computers will share the RAM and will be happy. No. But if you think about it, RAM speed matter. The CPU is constrained by how fast can you read data from the RAM. If RAM is being read by so many programs, that will also become the bottleneck along with the size. All right. The fourth thing which matters when we talk about computing Let's talk about third one, which is disk size and the speed. Disk speed is a bigger problem along with the size. So the disk hardly reads. It takes 5 minutes to read data, 1 GB data from normal hard drive. 5 minutes. Sorry, 5 seconds to read 1 GB of data from hard disk. 1 GB takes 5 seconds. Can you imagine this? Now, that too on a very fast computer. Okay, that too on a very fast computer, on a very fast hard drive. So the usual one takes far more time than that. And why does size matter in computing? Because if you're not able to fit the data on a hard disk, you will have to slice the data and put it somewhere else. And that will impact the computing overall. Similarly, the network, in case you have moved some of your local data onto network because disk was smaller, then network will come into play. Or you are doing some computing which needs to download the data from a network or save the data to the network, then your network becomes the bottleneck. All right. So all so these all the things, these all the components are a big concern when we talk about computing in general. All right. So is my voice clear to you? Because Veena is saying that she can't hear me. All right. Yes, Susant and Veena, you have raised your hand. Great. For others, the voice is very clear. So I'll continue. Good. So at least one of these four components becomes the bottleneck when we talk about big data, either CPU, RAM, disk, or the network. Okay, that's where when we try to do the computing on big data, the data which has those three properties, either of the three properties, any of these four components might become the bottleneck. Generally, when we talk about speed, the velocity will make your RAM the bottleneck. Okay, because every network connection needs to open a handle, and this handle consumes RAM, and therefore the number of connections a computer can open will fill up the RAM very quickly. Okay, the complexity, the variety part generally hits your CPU most. Okay, CPU and RAM. The the first one, the volume part, hits your network and the disk size. Okay, so because of the various V's we talk about, any of these components will become the bottleneck, and thereby you will require multiple set of multiple computers. And thereby, if you have multiple computers, then you need to design or use a tool which can utilize all the computers at the same time, and thereby you will have to use big data tools, or you will have to learn big data tools. All right, now fine, we understand that big data. Now, right now, we all understand that big data is a problem. But you might say, then what's the point of churning so much data? What is the point of churning so much data? The simple answer is, the bigger the data, the bigger is truth. Okay? If you have bigger data, you know the bigger truth. If you don't have bigger data, you don't know much truth. All right, so let's take few example of the systems where the big data is really useful. Let's see the web and e-commerce. In web and e-commerce, there are recommendation engines which recommend products to users. The bigger the data, the better is recommendation. Second is search quality. The autocomplete and the kind of search quality it has to provide, if it is not great, then it will not be useful for the user. Therefore, your search engine of any component, any internal or external, need to handle need to handle total number of requests really fast, as well as need to handle huge data. Along with that, it needs to know about your data really, really well. For that, you might have to process your data. Third is the sentiment analysis. For computing, who is talking about you what? You generally you generally like to go for sentiment analysis. And in sentiment analysis, when you have lot of data, only then it makes sense to do the sentiment computation. Therefore, big data in these domains make a lot of difference. Similarly, A/B testing. When you are testing your program, when you are, let's say you are running a company, e-commerce company, and you want to roll out a new feature or you want to change an existing feature, instead of instead of instead of launching it to all the users, you want to launch it only to few users and check whether the users are responding to us in a positive manner or negative manner. So A/B testing makes sense only if you have huge number of users. If you have only few number of users, A/B testing doesn't make any sense. In telecommunication, they can avoid their customer churn prevention if they can figure out why a customer is leaving. And it is possible because in case of telecom, they have so huge data that can be processed to figure out how many people left had how many number of calls, how many people who left were online for how many hours. So based on all the history of all the users, the telecom companies can avoid people leaving them. Second is the network performance optimization. All right. So to telecom companies, based on the data of the full year or last year, they can predict how much network it is going to hurt. Okay. And based on, say, Dasera is coming or Sims festival is coming, based on past history or the behavior of the users as well as population increase, they can predict how what kind of performance optimizations could be done in order to accommodate the current pattern, user pattern. Next is calling data record analysis. Based on calling data record analysis, they can give great offers to their users. And analyzing network to predict failure. They can also analyze the network. So if they can figure out that these are the signals which various equipments are sending and then failing. So if they have this record of past, they can do the prediction of network failure. And this is fairly possible because they have big data. Telecom have big data because there are so many customers, so many users, so many towers and so many geographical locations. So Venkat's question is, are we going to get these slides stored in our course? Yes, Venkat. Pankaj's question is, what is the difference between big data and BI tool? As BI is also used for analytics and reporting. All right, let me ask you a few questions. If there is a say 2 terabyte of data on which you have to run your BI tool, can you run it? Or let's take 100 terabyte data. Can you run your BI tool on that 100 terabyte data? Of course not. Because most of the BI tool talk to databases and databases falter when they have to deal with 100 terabyte data. Therefore, therefore, you would require BI tool at later point of time, but those BI tools will be connecting to the backend which is running on big data infrastructure. Second, the BI tools which we talk about did not do much of a prediction. Here, in case of big data tools, since the data is very huge, you can apply those statistical techniques to do the prediction. And the predictions are really valuable and make sense in case of big data. In case of small data, there was always this problem of whenever you try to predict something, it's generally very off the record. It's generally off the very off the results. So we could never we were never confident, and we did not trust the prediction too much in case of small data. But in case of big data, when you have a million record or a billion record about the user behavior, you can do the predictive analytics. And that is the difference between BI tools and these tools. Also, BI tools do not handle storage. BI tools are just one small section of the components required to solve our problem. Venkat's question is where they will be stored. I mean, I'm assuming that when they means those number of records, where will those number of records be stored? Generally, those are stored in a big data system. We'll talk about it as we go ahead. Susan's question is distributed computing similar to SOA? SOA. SOA is service oriented architecture. Service oriented architecture is just one thin layer of way of creating services. So rather than people talking to each other via writing into database, many companies realize that talking through the database between many teams is not really feasible. Therefore, they created something called service oriented architecture. When one product needs to talk to another, they call services rather than talking directly to the database. Okay, so that's just one layer of abstraction on top of the components. So almost all the big data tools have service oriented architecture. All right. These slides will be stored on our LMS and will be made available to you, Venkat. All right. The other example big data customers or big data problems that require to be solved is government for the fraud detection, for the cyber security welfare, and for the justice. For healthcare and life sciences, it is of very important use. The the health information exchange, gene sequencing, and healthcare improvement and drug discovery. All right. All right. Now, there is a question from Susant. Let me address it again. Is distributed computing similar to SOA? No. Okay. In service-oriented architecture, basically there are each component, each tool is exposing services. Okay. But that tool may not be running on multiple computers. So these are two different things. All right. These are two different things. One is any components, whether it's running on one computer or multiple computers, would expose service oriented architecture. All right. Like the front end tools expose the UI, the back end tools generally expose these services with which you can interact with the service, interact with the tool. Okay. So the actual tool, whether it's running on a single computer or multiple computers, is what describe it as distributed computing. All right. Do I make sense now, Susant? All right. A little bit more about recommendation. We talked about recommendation. It is very important to understand recommendations. There are many kind of recommendations. One is when you don't know about who is your user. Then you generally give the recommendation like customers who bought this item also bought this item. So even though we do not know about the user is not yet logged in, we are giving the recommendation. All right. Second is you can wear this particular cloth with these things. Here, in the first case, you needed the data about other customers. In the second case, it is hand curated. You don't need some other data. It is created by some people. Now, there is the second kind of recommendation, third kind of recommendation, where you know about the user based on their past history of rating various movies, and based on those ratings you give them the recommendation. You tell them that you basically show them clearly that these are the movies or these are the product you will like based on your past history of liking movies. Okay, so for example, here it says congratulations, these are the movies that we think you will love. All right. Now these are the movies they think that we will love. So therefore they're able to clearly predict what movies you will like. So these are the three kinds of recommendations we talked about: hand curated, product to product, and based on users' behavior. And it is very much possible today to do these kind of recommendation by using a tool like Mahat or MLlib from Spark. There are many such tools which can do the recommendation as of today, and it's like very, very simplified. You take user ID, movie ID, and ratings and feed it to Mahat, and it'll give you user ID, movie ID, and the ratings. How much this user will like this particular recommendation. Okay, so this is the recommendation value. It means that Kumar will definitely like Apocalypse Now. It's 4, but Giri will definitely like Matrix by the chances 4.5 out of 5. Okay, so such kind of tool has made the life of the developer really, really easy. We as a developer or architect do not need to know the internals of recommendation engine. We all we need to know is how to use this API, how to use this command line, which can convert my 3 column data into recommendations. Make sense to you? So this is how we generally generate the recommendation, and we will also cover it in detail during our session. Now, what exactly is sentiment analysis? Sentiment analysis is based on the public information, based on the various information available to from various sources, we try to predict how is the general sentiment about our product. What do people think about product or product services or new launch or whatever? How is it going? How are people responding to our new movie release? So this is called sentiment analysis. So generally we plot a graph where on x-axis there is a timeline, on y-axis there are two graphs which show positive and negative sentiment both. The points where, and also we mark with the points that on these dates we released various kinds of advertisements. On these dates we released various kinds of uh, various kinds of products. So we basically try to compare how is our product going in the industry, in the market. How is the customers or how is general public responding to our products? Okay, there are many signals which we can gather. One is how many likes, how many comments, and second is one is how much like, how many comments. Second is what are exactly they talking about. Are their sentences contain negative words, or are their sentences positive? Are the sentence really positive? So based on that, we compute the sentiments. We will cover a full example during the session. All right. Now here are common myths about big data. The 11 common myths about big data. Okay, is everybody with me? Great, great. The common myths about big data is it always means data above or in the range of terabytes. As we talked about variety, the third V out of those the characteristics of big data. So when we talked about variety, we told you that even though the data is small, it could become a trouble to one single machine for various reasons. One of them is the kind of problem are you trying to solve, or the kind of data you are trying to churn. So the data not necessarily has to be in terabytes. There are data in gigabytes which is very difficult to process or compute using one computer. Even the recommendation system is almost impossible to get it done in a considerable amount of reasonable amount of time in one computer. Okay, therefore generally the big data looks bigger, but that doesn't mean it has to be 1 terabyte. It has to be in terabytes. Is always about social media doesn't apply to me. No, it just so happens that most of the data use cases came into picture because of recommendation engine and sentiment analysis, but that doesn't mean that it is always only about social media. No, the systems which are built at in Mobi or Amazon for the internal processing, those were all related to internal. All right. It just so happens that we had so much of data in 100 terabytes, and we found the use case of using that data. Third is it will replace the enterprise data warehouse. Answer is no, it won't. Okay, because some part of enterprise data warehouses will be replaced by the newer systems, but if you are trying to keep the transactional data in EDW, that will not be removed. Some part of it will be removed, by the way. Second is, fourth is it just a buzzword? There are no practical applications. There are many practical applications. It's no longer a buzzword. It's new concept and will be the future. It's neither a new concept because there have been, as I was telling you, that in 2002 at DE Shaw is the place where Jeff Bezos, the CEO of Amazon, was working at DE Shaw earlier. Now, at DE Shaw, we were churning huge data before anybody else was doing. So, although people were doing internally, we were not telling anybody that we were doing it. We were not allowed to talk about it at that point of time. So, definitely, it's not a new concept. People have been doing it for quite some time. Now, it will be the future. No, it is the present. Okay. If you are still stuck with the handling small data, you need to figure it out. You need to figure out various use cases, or you need to see that are you deleting some data. Is expensive? No. Almost every tool is open source. Along with that, the hardware cost is quite low. You can utilize existing hardware. The only expensive is the finding the talent in this industry, which is a function of demand and supply. Eighth is only for data scientists or is magic? No, it's not for data scientists only. The algorithms which data scientists are building can be are sort of commodity and are all found in open source. You can use them directly. As I was showing you, the recommendation engine itself is like a commodity. You can just use off the self algorithm and get your work done. So it's neither a magic nor it's only for data scientists. We have enough hardware, don't need it anymore. So it's not about hardware. Okay. On the contrary, it's about lesser hardware, the smaller hardware, the usual hardware instead of server grade hardware. We will build it when we need it. Okay, so this is another paradox I find. Okay, we will build it when we need it, and since we haven't built it, we don't feel that there is a need of it, and therefore in case some need arises, we will ignore it and will continue to live by it. And therefore and by the moment the need arises, we realize that we don't have data, therefore that need is not real. All right, so that's a cyclic loop. If you if you if you are deleting or dropping the data of your customer at any point because you could not manage it, then that's a signal to you that you need a big data system. Now big data is about Hadoop? No, it's about a suite of components. There are many other components than Hadoop. Now let me take few questions. If you have any question, feel free to ask. So Siddhi's question is, um, so what is the limit of being qualified as big data? There is no limit per se. The only thing is, you generally ask this question, are you able to get work done using existing tools to a satisfaction level? When I say existing tool, it means the database or it means the file system. The existing tools to store unstructured data is your file system, where you dump any file, any data. And to existing tool to handle structured data is your RDBMS. So are you able to get your work done through these systems happily? Or maybe your web application which is trying to process a lot of data. Okay, so that's, if you are able to get work done, then your problem, it does not qualify to be called as big data problem. If not, then you need to solve it, okay, using the big data platform. All right, so Veena's question is, are small medium sized companies using big data now? So it all depends. Okay, it all depends. Okay, even a small, very small company might need a big data analysis if they are into the information business. Okay, so most of the companies are trying to transform themselves so that they can take the advantage of information. Okay, okay. Susan's question is, please explain the variety part of the data for big data, and please give one more example of variety. Now I'll take another example. All right. So I'll take another example. Another example is, you have 1 terabyte of data, or 1 terabyte of data containing information about the users. Okay. About the users, as in what is their name, where do they belong, what is their age, and what kind of articles they read, where all they have clicked in past, and how many products they have bought. So all of that data you have, and this data is around 1 terabyte data about hundreds of millions of users. Okay, so 1 terabyte is not that bigger data. Now, on top of this 1 terabyte data, you want to do a predictive analytics, or you want to do some sort of intelligence thing. Say, automatically make 20 groups out of this 1 TB data based on the various parameters. You have to just create 20 groups out of 1 terabyte data. It's actually a very difficult thing. First, you have to compute from, say, millions of users, about 100 million users. Okay, so out of 100 million users, you have to compute the distance between one user and another. So 100 million into 100 million, those many computation you have to do to find out what is the distance between one user and another, between how close are me and Sushant Avasti, and how close is Sushant and Siddhi, based on various similarities and dissimilarities. Now, once you have these similarities and dissimilarities, then you try to group them together. You try to automatically create, or let me just make it a little more further, automatically make groups out of 1 terabyte data. Do a hierarchical classification. Hierarchical classification is, we will build a big graph saying me and Sushant are closer to each other, Sushant and this person is closer to each other, so there will be another tree, and so on. So that's a kind of classification, we do that. And and to do that kind of classification, you have to compare every record with against every other record. And therefore, even though it's just 1 TB data which can be stored in one hard drive, but doing the actual computation will not be possible using one single computer. You'll have to distribute the computing to hundreds of computers parallelly. All right. So yes. Now there is another question. Let me finish the questions and then we will move ahead. All right. So another question from Ganpati is, I did not understand companies use big data. Big data is basically collection of large data and its management. Hadoop, one of the framework. So, okay. So whenever we say that companies are using big data, means they are utilizing big data technologies. Okay, that's what it means. They are utilizing the big data technologies in their day-to-day use. Big data is not something like an outsourced data. We are buying this data to do something. No. Big data, when we say I am benefiting from big data, it's generally a phrase used to say that we are utilizing big data technologies to solve our big data problem. Okay, so yes, Hadoop is one of the frameworks used for big data. So your understanding is correct, Ganpati. Now there's a next question. There's a next question from uh, Srini. Question is, do you know any example of big data solution applicable on small data sets around 100 gigabyte and structured data? Yes, of course. Okay, so even at 100 gigabyte, you try to do predictive analytics. Okay, analytics. Then predictive analytics that people are used to do on SaaS. You can't do it. You can't do it. Any analytics which you do using R or SAS on 100 gigabyte data, you cannot do using R or SAS. You immediately have to move to better solutions. Okay, because when you load some data into R on a single computer, it will overflow the memory, and thereby it's not possible to do it on the time. Even 100 gigabyte is a decent amount of data, because to just go through 100 gigabyte quickly, it takes around 500 seconds. okay, which is around 10 minutes. If you have to just compare the records of one against another, it takes a lot of time in 500 gigabyte data. All right. So does it make sense to you? So even if even if the movie recommendation example, even movie recommendation example would have less than 100 gigabyte data. All right. Next question from Sushant. This would be computational problem, not the big data problem. Pertaining, yes. So the data here sounds misnomer. Okay. Whenever we say big data and big data technology, it's not necessarily has to do with the volume. Okay. It also means it basically boils down to the distributed computing. It's a suite of frameworks. All the tools that we will discuss as part of this course will be related to distributed computing. So distributed computing we are using as alias to big data computing. All right. All right. Let's move on. All right. Let's take a break for 10 minutes and we'll be back by 10:17 p.m. IST. All right. Huh. Hello. All right, so I'm back. Should we start now? Actually, there were some calls which are coming to me, so I could not avoid taking them up. All right. So if you have any more question, we can discuss it now or later. So Srini, can I take up your question after this? Okay. Or maybe we can take it offline. Probably that would be better. Veena, I think we can take up your question after this. So could you just drop me an email? I mean, reach us at No Big Data. That comes to me also. I'll respond to it. All right, Srini? All right, Sushant, I'll have a look at it. Have a look at your screen uh, and understand what exactly is wrong. All right, let me try it out after this. All right, so these are the salary trends you see here. And this data is updated on April 12, 2015. Okay. And data is like Hadoop is fairly popular still, as in the salaries in Hadoop are really high, as well as the number of jobs are also the trend as per the time is actually growing up. Now you can have a look at this. This data was wrong because the date was because that year was not counted. Therefore, the data was looking smaller. But yeah, because it was taken on April 12th. That means that since it was on April 12th, only half of the month was counted. Therefore, the data only is valid up to before April. All right. So the point here is that the trend of salaries is really great in case of Hadoop. And after Hadoop comes your Java, MongoDB, and Oracle and JavaScript. All right. So that is a salary trend. Okay. Sushant's question is what is let me go into the details. All right. So there are many big data solutions who claim to be the solutions for big data, solving the problem of big data, and there are many. One is Hadoop, other is Spark, while Hadoop is probably the most complete one. Now Hadoop has included Spark in itself, so the this combination of Hadoop and Spark is probably the most complete big data solution. Hadoop comes with a great analytics engine and is a great way of using Hadoop, while Hadoop provides you the storage and other surrounding tools. Okay, so other than Hadoop and Spark, there is Cassandra. Cassandra is a database which provide you a way to do the computational on semi-structured or structured data. Same is the case with MongoDB. MongoDB is also another distributed database in which can handle really huge load of insertion and deletion, that insertion, updation or deletion of the data. And you can also do the computation on MongoDB. The third is Google Compute Engine, the likes of Google Compute Engine, I would say. In these kind of situation, this is software as a service, as in you have to upload your data to Google Computing environment. Only then you will be able to use Google Compute Engine to do various kinds of computation. All right, but sometimes this is not possible for various organizations. They don't want to expose their data and they don't want to put the data into Google Cloud. Okay, and Cassandra and MongoDB, they are like databases. They can handle really huge load of insertion updation, but they're not good enough when it comes to unstructured data or when it comes to really high quality algorithms. Okay, so for 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 most of the use case as of today, the best stack I found is Hadoop combined with Spark. If you have just the problem of velocity, as in there are so many users going to update your data, then instead of going with the full stack of Spark and Hadoop, you can either go for just Cassandra or just MongoDB. Let's say you are building a service which is going to get requests from lots of users, and right now you do not have any plans of any other analytics. So you can go for a lightweight solution such as Cassandra or MongoDB, which is just one service which you can install on multiple computers, and it will divide the workload amongst multiple computers. Okay, but if you go for Hadoop, it would require a lot of resources. Reason being, the Hadoop is a suite of component. It's not a single component. Hadoop is a full-blown suite. I'll show you various the whole ecosystem that you will understand. All right. So Susant, does it give you an idea what is MongoDB? MongoDB is a database which can be run on multitude of computers simultaneously, multiple computers simultaneously. All right. Now coming to Hadoop, let's just describe Hadoop. What is it? All right. The real clarity of thought will come when we discuss each and every component in detail. All right. So what exactly is Hadoop? Hadoop was created by Dog Cutting from Yahoo and Mike Caffarella. They were trying to build a search engine. When they were working at Yahoo, they were running their personal project, which they called as Nudge, and they were working part time on it so that they could derive they could build a good search engine. But they realized that to build a great search engine, they need big storage. Okay, because the existing storage could not solve their problem, and that's when Google published these papers on Google File System, Google MapReduce, and Google Bigtable. So Dog Cutting and Mike Caffarella, they implemented these three papers, and that's what became Hadoop. And since they kept Hadoop as open source, and that too under an Apache license, which is probably the most liberal license available on the internet. So that's why Hadoop became very popular. Hadoop became the de facto standard for storing petabytes of data. It's quite popular, powerful, and supported. It's a framework to handle big data. And the big data, the way Hadoop guys describe, we are going to stick to that term. They call reliable, scalable, and distributed computing. Okay, so every component that is under the umbrella of Hadoop. Okay, before I go there, so Hadoop started with three components: Hadoop Distributed File System (HDFS), that is just a basic file system. Then Hadoop MapReduce to run the computation, and Hadoop HBase. Okay, so out of the Hadoop started with these three components, and these three were the components with which it was started. But later on, Hadoop kept on adopting the various components under the same umbrella which were related to the Hadoop. Okay, so the components, the only condition which Hadoop guys kept was all the components that want to be adopted by Hadoop should be reliable, scalable, and distributed. Okay, therefore, and that's how we have the full around 12 components under the umbrella of Hadoop as of today. All right. Vina's question is, what is HBase for? You will get the answer, don't worry. Alright, so this is the basic definition of Hadoop. Hadoop was written first in Java so that it can run on any kind of device. Now here is, alright, alright, so here we are. Alright, so this is the ecosystem diagram of Hadoop, whereby the whole story starts with the Hadoop distributed file system. Hadoop distributed file system is a component where where you store the files. It's the main component of Hadoop, okay, under which everybody will be storing their data. So the say Hadoop database called HBase will be storing its file in the Hadoop distributed file system. So the way Hadoop distributed file system works is the way it works is that we install Hadoop distributed file system on multiple nodes, and then it stores the data on those multiple nodes. We'll go into the details of HDFS in a minute, maybe today, or if time permits, we'll go over HDFS today, or we will go over HDFS in the next session. So Hadoop distributed file system stores the files. Now you might ask that we already have C colon, D colon, and whatnot. Why are we having new file system? The answer is simple: to handle petabytes of data. So HDFS is nothing but is a process running on multiple computers simultaneously on thousands of computers, and to you it would look like as if it's a single service in which there is a file system. All right, and that's what is Hadoop distributed file system. Because if you try to create your own file system, you will get into many kind of complications. Okay, so the whole story starts with Hadoop distributed file system. Now, on the top of Hadoop distributed files, once you are able to store your files, now rest of the story starts. If you are not able to store your files, what will you compute? Now, on top of HDFS, there is the other component of Hadoop, which is most important, is Yarn. Yarn is like distributed operating system. The way in your computer, if you want to get something done, you tell operating system, please run this program. In the similar way, you you tell Yarn. Yarn is also running or also run on the whole cluster. So you tell Yarn that, hey, here is my program. Please run it on multiple computers, and Yarn runs it. Okay, but since it's difficult to tell Yarn it's impossible for Yarn to execute your normal program. Therefore you require a way of talking to Yarn, and that is MapReduce and Spark. So you write your code with respect to these paradigms like MapReduce and Spark, and they hand it over to Yarn, get the work done through Yarn, and then return the result to you. So whenever you have to do the processing, you ask the MapReduce or Spark to get the work done through through Yarn. So MapReduce runs on top of Yarn. Similarly, Spark also runs on top of Yarn, and so on. Now there is a fourth component called HBase. It's a fifth component actually. Fifth component called HBase. What is HBase? So we just now talked about storing files. What if you have to store records? Okay, your records, you cannot store, you can store records in normal files like in CSV, but if you have to frequently edit the values, if you have to edit a value in a file, what you do is you generally modify the whole file, which is equivalent to saving the file again, which is very inefficient. Therefore, when you have to edit the records, update the record, delete the records, then HBase is required. HBase is a NoSQL database. It's a database that internally uses HDFS and also uses MapReduce to get the computing done. Okay, so HBase is a very simple key value kind of store. We will go into the details of HBase. We'll go into the details of all of these components over 11 next 11 sessions. Now, on top of all of this, there are these components like Hive. So when you want to churn your data, when we say, let's say you have a huge CSV file and you want to find out some something like all the average salary of these many people, right? Average salary of the student. So that kind of computation is complex if you try to write it in MapReduce or even Spark. Those kind of computation is great if you try to write it in terms of SQL, and that's where Hive comes into play. That's where Hive comes into play. You tell Hive that, hey, all I want is here is my data. Can you run my SQL? And then Hive will take your SQL, tell the tell tell MapReduce that here is the can you run this MapReduce? So Hive will convert your SQL into MapReduce program and run it on Yarn. Okay, so Hive will convert your SQL into MapReduce and hand it over to MapReduce. MapReduce will run it over Yarn and give you the results. So that's where Hive comes into play. Hive can churn the data. So Hive can churn the data lying in HDFS, lying in HBase. Also, please note that when we talk about HBase, HBase does not provide you an SQL. HBase does not have a great interface like you have been using SQL. HBase sounds like database, but it's a simple data store. It does not qualify to be called as database. It's a data store. A data store which can store billions of columns and billions of rows. Or you can say millions of columns by billions of rows. And that's kind of data HBase can easily handle. All right. So now on top of it, we have Pig Latin. Pig Latin is very similar to Hive. Okay, so people realize that the SQL interface, SQL for Hive is not uh, really efficient. Therefore, they designed Pig Latin. Pig Latin is just like SQL. Instead, it's a little bit more simpler. So you tell Pig that, hey, here is my query, can you run this query? And the query is basically similar to your select statement, where clause, group by clause, and that kind of clauses. So you give pig the pig Latin, pig and converts that into MapReduce and executes it on the MapReduce. Alright. In the similar fashion, there is Mahat. Mahat is basically a collection of algorithms. Mahat has many algorithms built in, such as recommendation system, finding grouping, doing the classification, and there are many more magical things which Mahat brings into play. Okay, so any algorithm which you run on Mahat, when you say running the recommendation engine, internally Mahat is going to call MapReduce and get the work done. So any computation work generally either routes to the MapReduce or routes to the Spark. Any computation on this big data framework. All right. So all the code, all the logic for the computation, for the analytics, you will be writing, uh, and that will be executed via MapReduce or via Spark. Now, on top of it, if you have to interact with these components, you could use either the command lines or the UI or maybe the programming language like Python or Java. But please note that when you have a large project, okay, and there is a large project, there are many people working in it. So there might be a Java developer who might be writing the custom code. There might be an analyst who is writing an SQL to churn the data. There might be a data scientist who is improving upon the algorithms. So there could be many components in your project. Say the H based the developer is writing MapReduce logic. Okay, so that is one part. Second, the analyst has written piglet in queries. That is another part. There is another DBA or the BI person who has written Hive queries. Now, after cleaning data through Hive and MapReduce and Pig, you might want to run the algorithms provided by data scientists, which are written in Mahat. And once that is done, we want to push that data to somewhere. And that pushing the data to maybe SQL or somewhere is done through these tools like Scoop. All right. So we missed Flume and Scoop. Flume is a tool which basically pulls the data from across the network into HDFS. If you have 30 web servers and all of them are producing lot of logs, you can install Flume to pull the data from all the 30 nodes into one HDFS. Similarly, if you want to download data from Twitter, you can run Flume agent on 20 machines and it will download the data from Twitter and push it into HDFS. So Flume is for unstructured data, to push the unstructured data into Hadoop or into HDFS. And then there is Scoop. Scoop basically makes it possible to move data back and forth from and to into RDBMS. If you have something like MySQL, Oracle, or Microsoft SQL, and you want to pull the data from those kind of databases into either HDFS or HBase, you can use Scoop. Or if you want to take the records from HDFS, say there is a CSV file which is generated as a result of running the recommendation, and you want to move it to your web server, you will use Scoop for that kind of work. So your Mahat might have generated the results, and those results are recommendations. Like this person likes this movie based on the data which has been cleaned using various Piglet, Hive, or MapReduce algorithms. So you have cleaned the data, you have passed it to Mahat. Mahat has produced the recommendation. Now is the time to move these recommendations back to your web server. In those cases, you will use Scoop. And now you can see that in a typical project, you will have these components used, right? So you push your raw data. So I pushed the Apache logs using Flume. That was first component. Then I used Hive combined with Pigletin and MapReduce to clean my data in the 3-column format, like user ID, product ID, how much they like that product. Now we gave this to Mahat. Mahat gave us some results. Then we wrote some custom code to clean the results of Mahat. And once that was done, we moved it into Scoop. Okay. So there are so many components being used in a simple recommendation engine in the real life, and that's how it happens. So how do you make it happen? How do you make it happen that this storyboarding, that this component will do this much and after that the other component will run and after that some other will run? To make that happen properly, you need a workflow engine, and this workflow engine is like your Maven or Ant or Make, those kind of build tools, so that you can storyboard the task. You can create a directed acyclic graph of to-do list. All right. So that's where the Uzi comes into play. So that was a brief description of various components of this ecosystem. The components that are not here is called Zookeeper. Okay, Zookeeper is for storing small information about small information but highly available. So whenever people have to, just like you have in your Windows, you have regedit. So basically very small amount of information of settings. If you have to keep it centralized, you generally use Zookeeper for that, and we will cover Zookeeper in detail during this course. All right, because Zookeeper is something on which everybody depends upon, whether Kafka. Okay, so there are many tools which depend upon Zookeeper. So here are few questions, let me try to answer. Is HBase a new NoSQL database? If so, which software to be used for SQL database structured data on Hadoop? Okay, so yes, HBase is a NoSQL database, and the software to be used for SQL database and structured data on SCO is HBase. Okay, if you have, so there is no such thing, there is no SQL database. All right. Also, there is a slight confusion about the term called NoSQL. NoSQL means we are not able to provide SQL kind of properties, such as ACID properties. All right. NoSQL does not mean that we will not be able to store structured or semi-structured data. Okay. HBase does help you with storing the structured data, but not relational data, because HBase does not provide you primary secondary key, and none of the big data DBs provide you relational properties. Okay, they only provide you partly, be it MongoDB, be it Cassandra. None of them do provide you those relational properties. All right. Now Bala's question is, so will yarn will again convert and go to HBase for yes. So yarn can talk to anybody. Inside yarn, your code can talk to HBase, HDFS, or anybody. Okay, it all depends on, so yarn does not directly depend on HBase. It is your code which is running inside yarn, whether it wants to talk to HBase, whether it wants to talk to HDFS, or whether it wants to talk to MongoDB or some other database. Sushant's question is Pig Latin like Hibernate? Okay, let me give it a thought. So, what exactly is Hibernate? Hibernate is a layer which converts objects objects into relay table. Okay, that's what is Hibernate. Hibernate converts the objects into a tables row, right? So when you talk about Pig Latin is not that. Pig Latin converts your SQL like query, as Piglatin is a language, it's not a converter. I'll just be SQL like query called Latin, Piglatin. I'll say Piglatin gets converted into this. The SQL like Piglatin query gets converted into a MapReduce logic. Okay, that's the duty of Pig. Pig does that. Okay, Pig does that. All right, that is the duty of Piglatin and Hibernate. So can we compare HBase to any existing technology? You can compare to HBase to an Excel sheet. Okay, really big Excel sheet. Really big Excel sheet where you can add any cell anywhere. You can create as many as column you want. Okay, and so on. What is the difference between Hive and Pig? Are both SQL interface? So Hive is SQL while Pig is Pig Latin, and that has been designed bottom up so that the code can run really fast. So Pig is little faster than Hive, and Pig is able to handle semi-structured and unstructured data, while for Hive you need to format the data upfront. Next question from Srini is Spark written in Java? Yes. What kind of data? Okay, yes, it is written in Java, but it's basically written in Scala, in Scala, which internally runs in JVM. What kind of data stored in HBase as HDFS already used for storage? What kind of data is stored in HBase? Okay, so whenever you need a table, when let me ask you this: when do you store your data in normal file system like C colon, and when do you use a spreadsheet? So you use a spreadsheet whenever you need columns and rows, right? And whenever you just have to store the file as given to you, then you use file system. So it's exactly the same difference. Okay, so for whenever you have to store the data in table format, then you go with HBase. But if you are dumping the full object or something like a big file, then you can use HDFS directly. So HBase is installed on top of HDFS. Yes. So HBase, when you are creating record, just like any database, when you use any database like MySQL, for each table, MySQL creates a file. In the similar way, for the data stored in HBase, it stores it in the files in HDFS. All right. All right. Susan's question is, can you explain Scoop and Zookeeper once again? Do not panic because as we go ahead, we will do a deep dive into Scoop and Zookeeper, and then you will know what exactly are those. All right. So in very simple words, Scoop is a tool to move data from MySQL to HBase, MySQL to HBase or HDFS or Hive. Okay, although Hive stores in HDFS only, so let's not confuse. All right, now, so this is what Scoop does. and vice versa, and vice versa. So I'll just make one more array here saying this is what Scoop does. MySQL or Oracle or Microsoft SQL and so on. Sound good? Okay. So I think I have answered that question, Srini. Okay. This is answered, I guess. Veena's question is, what is the difference between MapReduce and Spark? MapReduce, I mean, for time being, you can understand MapReduce is a bit slower and batch-wise, while Spark is faster and utilizes RAM. Okay, so while the design of MapReduce was to consume lesser amount of RAM and get the stuff done, while Spark tries to utilize your RAM as much as possible to get the work done. Okay, so which means Spark runs better when you have better RAM, but MapReduce runs almost on every size of RAM. So that is the difference. We will go into the details again when we, I mean, this will make more sense when you actually understand what does it mean by Spark and what does it mean by MapReduce. The difference will be bigger when you try to understand both. Okay, we will go over both in detail, so no worries. Is Hive or Pigletin be considered as a library to create MapReduce program? Yes, you can think of that way. Yes, you can think of that way. Okay, that way, but is it doesn't give you back the MapReduce. It gets it done and returns you the results. Okay, okay, but it doesn't give you the MapReduce program. Instead, it gets MapReduce program executed on Yarn and gives you the result. All right. Now, Ganpati's question is, do we need MapReduce if we are using Pigletin or HBase? Very good question, I would say. So, yes or no? So for HBase, you cannot do any computation in HBase. HBase does not provide you. Okay, let me just break it down. Probably you mean to say Hive here. Okay, so all right, probably you mean to say Hive. Oh yeah, yeah, you have written in the next line. Good, good. Now question is, do we need MapReduce if we use Pigletin or Hive? Yes, sometimes. If you so Pigletin provides you a list of functions, as well as Pigletin provides you a way to create UDF. Okay, so Pigletin and Hive provide you list of functions and also a way to define UDF, user defined functions. Okay, provide you define custom functions. Pigletin and Hive, pig and Hive, let's not use extra word. Pig and Hive both provide you a library of functions and also a way to define custom functions. Okay. Now, when you need to define custom functions, those are done using Java and Python both. Okay, you can create your custom function using Java or Python both. But sometimes there are some problems which are better done using MapReduce directly. Specifically, problems not related to the tabular structure. Whenever you have to process the tabular structure, then this is good. But imagine if you are writing a complex algorithm related to, say, related to the same thing as recommendation. Say you realize that the kind of recommendation you need is not provided by Mahat library. In those cases, you will have to write your own MapReduce. Or there is a special format which is not being dealt with in PIC. Then you have to write your MapReduce custom input formats. Good question. John's question is, are there any softwares like HBase, Cassandra, MongoDB, Accumulo, and around 120 more? All of them are basically NoSQL databases. Installed on installed on HDFS? No. Yeah, his further follow-up question was, are there any other software like HBase which are installed on HDFS? No. All right. Ganpati's question is, can you list minimum software components needed for a big data installation? So if you are learning with us, you will not require anything to be installed. Everything will be available on CloudX Lab. Okay. And in case you are going for your cluster, you want to install on cluster, then what you can do is you can basically install Ambari, and that's it. Okay, Ambari will install all the softwares that are required. Okay, Ganpati, it will be better if you help me in understanding your objective. Okay, are you trying to install for learning, for your data center, or for this particular class? All right, there was one more thing I missed earlier. Yeah, now zookeeper is something I forgot to explain. Thank you, Susant, for reminding. What exactly is zookeeper? Okay, so let us say there are two persons, me and you, trying to coordinate. I tell that, okay, if you see if you see this particular how should I say, okay, me and you are trying to coordinate in making calls to thousands of users. Okay, so what we me and you decide is that we will write on the whiteboard saying whether you are busy or I am busy. Okay, if whatever customer you are making a call to, you just write it down on this whiteboard, if so that I don't call the same customer. All right, so that's how we decided, and this whiteboard is basically a zookeeper. it's an online it's an online highly available system in which various components who want to coordinate with each other can write their small amount of information. Okay, so that they can coordinate with each other very well. Yes, Veena, I'll be sharing this notepad, no worries. Okay. Bala's question is, can you explain one more time about yarn? All right. So when you ask yarn to do things, okay, say you are building. So generally, you don't talk to yarn directly. You ask MapReduce to talk to yarn directly. Okay, and MapReduce talks to yarn in the way like, hey, I'm trying to run this program near this file. Okay, wherever this file is located in HDFS, please run this program near to that file. Now yarn will find out, okay, this file is located on those nodes, and we have those many computers free on that particular location. Let's execute this logic on that node. So that is the duty of yarn. Yarn makes sure that your program runs. Okay, in case yarn one this program fails to execute on one particular node, yarn will execute on any other node and will make sure that it runs near the data if it wants to. All right. So yarn is kind of a distributed operating system. It runs your program in the network to give you the result. It's highly resilient in the way that in case something fails, it transfers the work to somebody else, somewhere else, and get it done. Okay. So that is the duty of yarn. Make sense to you, Bala? So, John, did you get your answer related to HBase? Same question is from Srini also, that can other NoSQL DBs be used with Hadoop as a replacement for HBase? Yes, kind of, but will not be able to utilize the HDFS much. All right. Now there is a very good set of question. All right. I would like to devote more time in answering the question rather than completing the syllabus right now. All right. Okay, so here are a few more questions. What will be the steps if you want to convert a small enterprise data system to to a big data system? That's a tough call to make. That's a tough question to answer. That is Sushant's way. So first you need to understand where exactly you need big data system, and you do not convert. Okay, you do not convert. You just establish a new systems. All right, so you don't just replace it. There is no direct replacement. It's just an expansion. Okay, so first would be figure out the need and applications. Install a new cluster. Install a cluster of maybe Hadoop, and start moving some of the data to the cluster. Okay, so figure out the need and the application, and then you start moving some of the data to HDFS or HBase. Okay, and later on you expose this whole cluster to all your developers so that they can build the useful application on top of Hadoop. All right. Naveen's question is Cloudera VM good? I personally don't like this VM stuff. If I have to basically get things done, I will actually buy a cluster, because these VMs do not teach you much. Okay, reason being, VM is a single node, and the whole big data concept is about multiple computers. So that's why I have installed our own cloud lab, so that all the students get a feel of a cluster. Okay. So, moreover, we generally I have tried all the both of them, Cloudera and Hortonworks, and we found Hortonworks far better. Okay, we found Hortonworks far better. All right. Okay. So Bala's point is Zookeeper like source control? Is that you meant? So you can say it in that way because it stores a small amount of information, and in source control it maintains the history of the source. Here it is not. All right. So in a way, the way source control resolves the conflicts, source control makes sure that people are able to resolve the conflict by matching the history and the changes. Similarly, zookeeper helps many people coordinate. In that sense of coordination between many people, zookeeper and source control are correct, right? But this is for many services, not with for the people. All right. Now, next question is, which component is responsible for parallel processing in Hadoop architecture? It is yarn. Okay, yarn as well as MapReduce, as well as the Spark. All of them are equally responsible for parallel processing, or you can say distributed computing. So Ravi's question is, where does the memcache or other caching solution comes into play? Okay, so generally caching solutions are good when people are trying to access your solution and you don't want to read the data again and again from the database or the file system, right? So here there is no caching solution because we don't want to cache anything right now. All right. Very good set of questions. Suppose I have this that was okay. Suppose I have Oracle, Sybase, and DB2 database in my traditional system. I want to implement big data technology. Okay. So you will basically you will copy slash move the data slash tables selectively. Okay, you will not simply replace them as such because for there is no alternative still to rdbms on for humongous data. You cannot get the relational database for huge data. Next question is, the cloud access which you provide, is it clustered? Of course, yes, of course, because that is the objective. All right, otherwise what's the point of learning if you don't run in the clustered environment? All right. All right, now Veena is asking, can you explain three logins in cloud lab? Ambari, Hue, and Console. I'll explain you in a minute. All right, I'll explain to you. All right, let me first show you. Okay, so when you log in into your account, all right. So I'm assuming that, all right. I think for you the account has not been created yet for that particular course. Let me just show you the previous course. We'll do it after this today's session. Let's see. Let's take a case of here. All right. So there is a username. Okay. there is login and there is a password. All right. Now there is a username, there is a login, and there is a password. I'm not going to show. I'll show the password. I'll just copy paste. Now all of these services, what I had just described in the ecosystem, have been installed on our cluster. So you can log in onto the cluster. Okay, it is Hadoop 17. I'll just log out from admin interface. So we'll say Hadoop 17 and log in. All right. So now you can see that there is HDFS. There are four nodes alive right now, and there is name node. We will talk about all of these details, as in what do each of these things do. Okay. And you can see the configs of each one. All right. It's just that everything is in a read-only mode. All right. So you can see that yarn is also installed. Yarn is, there are these many nodes alive running parallelly. MapReduce is also installed. HBase is saying that out of three nodes, only two is alive. One is dead. It will run again. Then you have Uzi, you have Zookeeper, you have Pig, you have Scoop, and then you have Hive. Okay, so everything is running on the cluster. Right now, we have installed, this is the older version. We are upgrading to our CloudX Lab. This is our newer CloudX Lab. We are upgrading to that one, which is Hadoop 2.7, and it has everything which you require. All right. Now, you can see that all of these are installed. So Ambari is for sysadmins to see the health of your cluster. All right. So Ambari is for sysadmins who want to keep an eye on the keep on monitoring their cluster as well as provision the cluster. When I say provision, it means that they can add more computers to it by simply clicking on add host. If you click on add host, it will ask for the IP address. You give the login password and it will install all the components that you select on that particular host. On the new host, it is very simple. So you can provision, monitor, and administer for using Ambari. You can do provision, monitor, and administer your cluster using Ambari. Now there is Hue. Let's try to log in Hue. So this is only for student, by the way. Okay, those who have enrolled in our course, the cluster is only available to them. We are opening up the cluster to everybody. That will be available very soon. Okay, we are opening up soon, so that even if you don't purchase our course, you will be able to attend. All right, you will be able to use our cluster. There will be later point of time. Right, so now we are logged in into Hue. And what is Hue? Hue makes it possible to run, uh, to basically mm, interact with all the components. This is your HDFS. You see, this is HDFS. This is where people's file are stored. Okay, our sample data which you will be working on is here. Okay, there's a sentiment file, there are Flume, there is Hive, there is the movie lens data regarding movie recommendation is here, and then you have Spark data, which is for various reasons, and you have all the things that are required, like for Pig, the custom piggy bank is available here. So almost every data that we require for the course is kept in this folder, which is only read only. You cannot, the students cannot delete this data or change this data. All right. So that's for course, so that when you are trying to run any of your program, you can just copy the data from here, or you can directly access the data using a program from this folder directly and start using. So this is this way you can interact with file browser. Next is you can interact with pig. Okay, you can write your pig query here and then execute it. Okay, you can say, for example, I'm trying to load a particular file and then dump it. That's it. You can run it from here itself. All right. Second is, if you want to run your SQL query against HDFS files, if you want to run your Hive, meaning run your Hive query, Hive SQL query, then you can type your query here and then execute. You can select the database you want against which you want to run the query. And that's how you can interact with Hive. So using Hue, you can interact with various tools. Hive, Pig, then this is the catalog, Hive catalog. You can browse the tables, create the table, browse the data, and so on. You can interact with file browser, and then and then file browser means HDFS. Okay, and then you can also look at the jobs which are running in your HDFS cluster. Okay, you can do that. Next is, if you are trying to create Uzi jobs, if you are trying to create Uzi jobs, then you can create a basically a workflow using this beautiful UI. You can say create, and as part of it, as part of your workflow, you can drag and drop various processes. Say you want to execute your Hive query, you can drag and drop the Hive query, okay, and specify the query. Similarly, you can create this beautiful workflow using Oozie, and that too from the Hue interface. So this is the interface provided by Hue. All right, and this is something you can do here. All right, these are the various other users available in the system. Good. So this is how you can interact with various services using UI. Now, if you want to interact with the various services from the terminal, so instead of you trying to install putty or anything, we have made everything available in the browser itself. So you can log in into your account here, okay, and then interact with all the services from here. Say I'm interacting with HDFS right now. I'm saying Hadoop fs minus ls. Okay, so this will give me a list of files. If I have to run my pig prompt, I can just say pig here, and here is my prompt where I can see where I can execute my pig Latin queries. Okay, so I can run my pig Latin queries here. Similarly, I can run my Hive queries. All right. Similarly, I can run Zookeeper from here and everything just from the command prompt. Okay. Now let's say I want to run Spark. Let's say I say user lib Spark, user lib Spark bin PySpark. All right. Okay. Okay. For this, you have to log in into. Okay. So here I have installed locally also. All right. So we have, all right. I think it's not there. So I'll just log in from here to my first node, Hadoop 17 at hadoop1.nobigdata.com. I'm trying to log in into my cluster from here. I mean, the first node. Let me copy the password. Oh, I've given a wrong name. All right. Now, if I run user lib spark bin spark bin PySpark. So I'll be able to run Spark interface from here. So I did not have to install anything on my local local machine. I'm just using the Cloud Labs for various things. All right. All right. So that was the difference between the three things. One was Ambari, Hue, and Console. Ambari is for administrators. Hue is for those developers who want to use the UI. Console is for those developers who want to use the console for interacting with various services. All right. So that explains. Yeah. So Vina's point is, so basically a developer will be working on Hue and console. Yes, that's correct. But generally, a developer has to do everything. Might have to change the configuration, might have to reinstall things. All right. All right. So there's a question from Pavan. Question is, do we get to know this cluster setup as part of this course? We will go with a very simple installation using Ambari. Okay, we'll explain to you how it is done. That's it. We will not go into too much of detail about administration because this course is not about administration. All right. Now there's a question from Bala. When you mentioned when you mentioned copy move table selectively, is it moving to flat files? Yes, and also to HBase. All right. So yeah. So Naveen's question is, how will we access your cluster? So not everybody is will be only the students who have enrolled in our course will be able to use the cluster. Okay. Yes, of course. Okay. So the question from Bala is, can we practice the exercise multiple times for the sake of practice and understanding in the cloud? Yes, of course. That's what is the freedom about. That's why we are providing you the console, and that's why you can try it as many times as you want. Just be considerate. Do not try to overload the cluster. Okay. So Ganpati's question is, where are these data stored physically? Okay, like movie data. So here we showed you, his question is good. Here we showed you that there is movie data, movie lens data. They look like files. Where is it stored physically? So those are broken into pieces and are stored on multiple nodes into in small blocks. We will cover it. We will cover it when we discuss about HDFS. So this data is stored in HDFS, which indirectly stores in local file system. And how is that translation happening? We'll talk about it in the tomorrow's discussion. Okay. All right. Bala's question is regarding the access. Does the system install anything? No, it doesn't install anything at all. The only thing we needed earlier was the putty, but that too we have moved to browser. Everything can be done through the browser itself. I mean, when you work in an organization, even on the testing of Hadoop, you never install virtual machine. Instead, there is a dedicated testing cluster available to you on which you run your development tools. All right, you do not install virtual machines. All right, so that was pretty much, and we are on the time. Okay, a quick review. So we have Cloud Labs, probably you all know about it. Those who have enrolled for the course, please go through Ambari, Hue, and also go through the LMS. You will be able to finish half of the quiz now and half of the quiz after the second session. And and also see the assignment section on LMS. There are a few more questions. If you are interested more about Hadoop, you can go with Apache Hadoop. If you are looking for a book, go with something called Definitive Guide to Hadoop. That's good. And further detail about Hadoop and HDFS design is listed here. Okay, so Justin's question is, what time is tomorrow's class? Same time as today, which means 3 hours ago from now. Right now it is 11:30, so the class starts at 8:30. So Justin's question is, do you offer Hadoop admin course? Right now, no, no. But the way we will describe to you the Ambari agent is done, you would not need too much anything other than that to get your cluster done. Because when I talk to even people at InMobi and people at other places where they are running the clusters, they are all using Ambaris and the cloud managers. That's all. Okay. Will you be sending? So the login will appear in the LMS. Okay. The login will appear in LMS. Okay. So I'll not be sending an email. It will appear in the LMS. How should I enroll for the course? You can go to Know Big Data, Know bigdata.com. Here. Okay, and then enroll. For me, it's showing in dollar because that's how we have set. Okay, so you can enroll there. All right, Siddhi, you can just go to the website. It will show you in INR, and it will show you in the always in the browser time zone. Okay. All right. All right, Siddhi, we will send you these details as well. And actually, you can directly go to the website and enroll because inevitably you will have to enroll there. Okay, there is no other way than there is no other discount or there is no other way than enrolling on the website. Yes, yes. So John's question is, will this video be recorded? Yes, it is already recorded. We will be sending you. Okay, along with the slides. Yes, Veena. The user ID will appear in the LMS for the cloud. Okay, we will make that available. Is it possible to switch evening session after attending? Yes, you can switch to another class. Just that you can only make one move. You cannot keep moving the course between the courses. All right. All right. All right, Siddhi. If you have any problems, feel free to write to us at reachus at Novig Data, or okay, or feel free to call us on these any of these numbers. All right. So feel free to write to us at reachus at novigdata.com. Okay. And if you have any doubts, feel free. And there were some more questions. Can you please send those in emails? Okay. There were some more questions after the break. I had said that I'll take them offline. Could you send those in the email? All right. Thank you very much. So that was pretty much about the class. And feel free to stay connected. Even if you are not enrolling, stay connected. All right. And okay. So that's pretty much about the course. Feel free to 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 let us know if you have any other questions. Also, there is a forum on which you can ask your question. Okay. There are many sections in this, and there are people who keep on asking questions here. All right. All right, it was a great session, great set of questions. Thank you, everyone. I'm really happy with the kind of questions you have asked. All right, great then. Thank you very much. Have a great day ahead. Bye bye.